So now we have learned about few of the techniques on how to create some models. For example, if I have to create something like knife base or KNN or SVM, if you have not yet gone through those modules, you will come across them. But by now, at least you have seen one or two algorithms. So we do already have a few algorithms in front of us and we are solving a problem. Now, a natural question which comes to us is that how to choose that which algorithm is best suitable for us. Uh, should we create a model with SVM? Should we create a model with KNN? Should we create a model with any other algorithm? So, what is the way we can decide on this factor? Is there any comparison metric for us which can tell us that okay, this is a good model or this is a bad model? Yes, we have seen few terms like accuracy, which definitely is going to help us into this regard, but at the same time, we definitely need to have few insights before we go and solve few of them, right? Now, this section is going to be little generic in that sense to give you insight that when you will be solving the real world problems, what are the things you need to keep in mind. There might be few things which you may feel are kind of again repeating in nature, and that is intentionally done to have a quick review. And even if it is going to be a little repetitive, uh, I'm going to explain it with a little different example so that you can basically relate the same concept with some extra examples in that case. Now, similar to that, like we discussed in regression, we have something called as linear regression. Now we do have quadratic equations. When you will move ahead, you will learn something like polynomial regressions, generic regressions, where you have equations like y, instead of just having like y is equal to mx plus c, maybe my equation could turn into mx1 square plus m2x2 square plus c, like this. Which equation is better to go for? Should we go for quadratic linear regression or should we go for normal simple linear regression? These are the questions I'm pretty sure all of you might be having, like how you can make a choice of a particular algorithm, what are the trade-offs required for them, and how we can compare two different models. Now, I'm pretty sure there is no definite answer for all this. You can't really come up with some one answer and say that this is gonna be thumb rule for everything up. But yes, we can follow some tips and tricks to reach to a particular conclusion. So, what are the methods or ways we can think of it? A lot of you may agree that sometimes we may have to do some trial and error, compare some metric like R square or accuracy and see which is doing better. Or sometimes even the domain knowledge helps. Maybe you know that in this specific sort of problem statement, since the problem is related to this domain, this is going to suit this kind of requirement more. Think of an example now so that we can relate more things with it. Let's say you are developing email spam detection and you might would look like to go with multiple sort of things like logistic regression, SVM and knife base, and you started creating your model on top of it. Now, what you are doing with this part, you have a lot of training data using which you are going to build your model. And what would be your end part? You gonna deliver that model to your client. Now, for a client is not going to run that model on basically already seen data on which you have created this model. In fact, what client expectation would be that if any random new email will comes up, he should get the output whether it's a spam or non-spam. So for the client, it's completely unseen data for which he would be expecting that you would be giving him more appropriate results. So that is the part. Now, definitely a question comes that which is better? Should we go for SVM? Should we go for knife base or so? Um, is it only the accuracy, the measure using which we can decide this? Maybe the answer could be no. And I would tell you that we also consider few more things while building these models and before we give it to the client. Let's take another example of, if you recall your days when you learned the driving of a car, you might have a coach sitting nearby to you, and he might be guiding you throughout the sessions that do this or do that, and basically you will be becoming a good driver in that case. But once you obtain your driving license or once your driving training gets over, now your expectation would be that you have to go around and without any help, no mentor being available with you, you have to drive on the roads. And specifically, if you are in India, you might be aware that you're not going to get everywhere the same road conditions what you might have used for the training set. But if you have learned your basics well, then you will be able to drive in that case, right? But if the training was done on a very specific route, that okay, if there is a no one is there on that road and you are just being taught that okay, how to put the gear and run the car on that road, and there was no traffic on that road and you're being trained on that, maybe if you go on when you get the license and when you start driving on the rushy road, you may not be able to perform that well, right? So this is the same analogy which will be applicable in the machine learning models as well. While choosing a model, we also look at one very interesting principle called as Occam's razor principle. This is one of the principle which states that your model should be as simple as possible, but definitely not as simple that it should become naive, but it should be as simple as possible. Now, what we really mean by this particular statement, so as I said, model can be as simple as possible. So what do you mean by model? From our previous learning what we have done, a model can be a data structure, it can be a function, it can be an algorithm, right? So what you are doing to it, you are passing some input, maybe email, and you are passing it to a model, which could be a data structure or a function or an algorithm, and you get an output. Maybe you are just telling that whether the email could be spam or non-spam, right? That could be your possible output in this case. Now, when we are drawing this, let's say on this example where your x could be a speed and y could be a mileage, and maybe you have got this kind of distribution of the data. So in that case, maybe you can get a straight line which said that y is equal to 3x plus c. In other term, if I have to put it for you, then you are getting some sort of conditions, right? That if this is the case, then maybe it's this, yes, otherwise it's not, yes, it's a no. So something like that is what we used to get. Now let's say there is a different distribution which you are getting, and for this you created this model. Now in this case, maybe your equation comes out to be this. Now many of you would agree, if I ask you which model is simple in this case, then you would say that this model is simpler in comparison to the other model. Let's take one more example to understand what you mean by simple model. Now, let's say you have created some decision tree where you said that if it's yes, go this side, if it's no, go this side. Now, you kept on building the tree, maybe till the depth of 50. You created another tree for which the depth is, let's say, 3. And now if I ask you which is going to be more simple model, you would say definitely with the value 3, it is going to be more simpler. One more last example. If let's say I have one equation this, which is also going to be linear equation, and second equation as this, then it's also a linear equation. And now if I ask you which is the more simple model, your answer would be that this is looking like more simple model. Though it's very subjective that which model you would like to call it simple, but in terms of if you want to store these coefficients and decide that how much space it's going to take, you would definitely say that this is going to take less space in comparison to this, because here you have floating point representation and here it's just integer values, right? Now, what we basically mean by simplicity of part, let me give you one or two examples. We sometimes have come across situations where one model is giving me an accuracy of, let's say, 90%, but this model is complex. There is another model on the other hand which is maybe making 87% accuracy. Now, which model you are going to choose? But this model is simpler. Okay, so this model is simple, this is complex. So when you will be giving your basically the solution to your client, you would be looking at the simpler model as far as the accuracy is not very bad. Means I'm just taking an example of accuracy, but it could be any other metric if let's say it's a regression problem. So you would be following this women's razor principle before you give it to the client, because we believe that we want to have more simpler models than the complex model, because complex model may not work that good on the unseen data, as I told you in the example of email spam detection, where we are not sure whether it's going to be a good data or not. So basically it's going to behave well on the new data or not. So this is where we would like to give the client more simpler model to be running on my production system. This is just some intuition about how you can go with your model selection.